Hello everyone, welcome back to my channel. In today's video, we are going to teach the graph traversals. What is graph traversal? Graph traversals refers to process of visiting or traversing through all the nodes and edges in a graph in a systematic way. The goal is to explore each part of the graph, often to find a particular node or path. There are two main types of graph traversal. First one, depth first search. Second one, uh, breadth first search. Now we take first one. What is meaning of depth first search? Depth first search is an algorithm for traversing or searching graphs to tree explore as deeply as possible along each branch before backtracking. Applications of depth first search. First one, find a path of between nodes. Second one, detecting cycles in a graph. Third one, solving meshes and puzzles. Fourth one, apologicals, sortings in directed graphs. Fifth one, identify connected component in a graph. Now let's look at depth first search in a graph. A depth first search graph is a simple graph starting with a node and going as deeply as possible. Now it is started with uh, a from A we can go to B and C. Let's go to B. After going to B, we can go to D and E. Let's go to E. From E, we can go to D. From D, we can go to C. Uh, okay, now we have nowhere to go again. We are going back to the previous D node, going to D to see if there's a place we can go, but there is nowhere to go. Then go back to B. There's nowhere new to go. Then go back to A. There is no way new to go. Uh, there are many answers we can get this way. The answer is always the same. It just changes depending on the path we take. So this is how to depth first search works. Our um, goal is to traverse every element in a graph. This is the example for depth first search. In department first search, we need to stack. We have found a simple graph like this. So first step is visited array is empty and stack also empty. So step 2, A push into the stack. Then the top element is pop. So visited array A is the visited one. So result is A. Step 3, uh, stack is empty. Steps 4, after B and C has the adjacency elements of A, so B and C push into stack. Then the top element is pop. Visited array A, B, C are visited. Result is A and C. Steps 5, after exploration C, A and D as the adjacency elements of C, but D is unvisited. Then D is push into the stack and the top of element is pop. So visited array A, B, C, D. Result is A, C, D. Step 6. After explorations D, C, D and E has the adjacency elements of a D. But E is unvisited. Then E is pushed into the stack and the top element is pop. Visited array A, B, C, D, E. Result is A, C, D, E. Step 7. After explorations E has adjacency elements, but there are no unvisited one. Then the top element is pop. Visited array A, B, C, D, E. Result A, C, D, E, B. Step 8. After explorations B has adjacency elements, but there are no unvisited one. So no more elements visited be added to the stack. Now stack is empty. Uh, Visited array A, B, C, D, E. Result A, C, D, E, B. So stack is empty. Now we can move code part of the depth first search. This program started by defining a graph with six vertices. A graph is represented as an adjacency list where each vertex has a list of connected neighboring vertices. Uh, Integer v equals 6 number of vertices. Linked list integer adj equals new linked list v. We initialize an array of linked list where each entry in the array represent a vertex and the corresponding linked list is to its neighbor. The number of vertices V is set to 6 and adjacency list is created where each vertex will have list of connected vertices. Adding edges. um Adding edges. The programs manually adds edges to the graph to define its structure. These edges shows which vertices are connected to each other. Before performing the DFS traversals, we initialize a Booleans array visited to keep track of which vertices have already been visited during the traversals. Uh, Boolean visited equal new Boolean v. The visited array will prevent revisited vertices and ensure that each vertex is explored only once. DFS function. The programs defines a recursive functions DFS method to perform the depth first search. The functions is called starting from vertex 0. Public static void DFS link list integer adj int not boolean visited. um, the functions receives the adjacency list adj, the current vertex node and the visited array. It marks the current vertex as visited node equal true and then print it out. The functions then recursive over all the unvisited neighbors of the current vertex. For each unvisited neighbor, DFS method is called again, efficiently exploring the graph in a depth first manner. So now we move to breadth first search. Uh, Breadth first search is an algorithm that visits all the nodes in a graph or tree level by level. It started from given node. It explores all neighbors first before moving to the next level. Applications of breadth first search. First one, shorted path in unweighted graphs. Second, finding connected component in a graph. Third, web crawling. Fourth, level order traversal in trees. Five, peer-to-peer networks for massive